हेलो गाइस, इस लेक्चर में स्टार्ट करते हैं बीजेटी वर्सेस फैट। क्या क्या इनमें डिफरेंस होते हैं, क्या क्या सिमिलरिटीज होती हैं। ठीक है, तो स्टार्ट करते हैं बीजेटी वर्सेस फैट। नाउ बोथ ऑफ दीज टू आर द ट्रांजिस्टर फैमिली डिवाइस, बट one is working on one effect and another is working on another effect. So फर्स्ट पॉइंट देखते हैं। फर्स्ट पॉइंट अगर मैं बात करता हूं, कंस्ट्रक्शन से स्टार्ट करते हैं, कंस्ट्रक्शन या एलिमेंट से। तो अगर मैं कंस्ट्रक्शन की बात करूं, हियर वी आर हैविंग द बीजेटी इज नोन एज फॉर थ्री टर्मिनल डिवाइस। बीजेटी इज नोन फॉर थ्री टर्मिनल डिवाइस। बेस, इट इज फर्स्ट वन इज बेस, then we have emitter, and then we have collector. So base, we have base, emitter and collector. Now in case of FET, we have three or more terminal, three or four terminal. Now 3 is for JFET, that is called gate, drain and source. For MOSFET we have four terminal like gate, drain, source and substrate. It is substrate. ठीक है यहाँ तक। Now what is the similarity between these three things? So it is gate, it is source and it is drain. Okay, now so the base is similar to gate, and emitter is similar to source, and collector is similar to what? Drain. Clear है यहाँ तक? So this is the first point, that is emitter, base, collector is similar to what? Gate, source and drain. Now second point, वर्किंग। अगर मैं वर्किंग की बात करूं या कॉन्सेप्ट की बात करूं तो ये किस प्रिंसिपल पर काम ये करते हैं। सो इन बीजेटी इनपुट करंट कंट्रोल दी output current, that is IB. This IB is input current and this is controlling the IC. So IC equals to, you have beta IB, the common emitter configuration के लिए. So we have linear relation between the input and output. Clear? Now that's why this BJT is known as controlled current source. So BJT is known as for controlled current source. But in case of FET, this input voltage, this gate to source voltage will decide this output current. So here input voltage control the output current. So FET is a voltage controlled device. ठीक है यहाँ तक? So it is a current controlled device. Now you can say that it is a current controlled device. BJT can be termed as current controlled device or element. ठीक है, device. Now next point इसी में हम लोग समझते हैं। Now we have two type of FET. So JFET is working as a voltage controlled current source, but the MOSFET is working as a voltage controlled capacitor. ठीक है, आई होप सो दोनों पॉइंट क्लियर हो गए होंगे ना। थर्ड पॉइंट की बात करते हैं, थर्ड पॉइंट की। ठीक है, now in case of BJT we have two types of carriers. So current का जो कंडक्शन वो कैसे होता है। So in BJT current is due to both electrons and holes. That's why its name is bipolar junction transistor. So it is bipolar device. Is it okay? Now अगर हम फैट की बात करें, it is unipolar device. device, because the current conduction is due to what? Majority charge carrier. That's why it is called unipolar device. Clear है? So current conduction is only due to majority चार्ज कैरियर्स. ठीक है बेटा, यहाँ तक. तो आई होप सो जो तीनों पॉइंट अभी तक आपको क्लियर हो गए होंगे कि बीजेटी और फैट में क्या क्या सिमिलरिटीज हैं, क्या क्या डिससिमिलरिटीज हैं. नाउ फोर्थ पॉइंट स्टार्ट करते हैं. नाउ फोर्थ पॉइंट से स्टार्ट करते हैं कि फोर्थ पॉइंट से डिफरेंस या सिमिलरिटीज बीजेटीज में और मॉसफेट में क्या होती हैं. ठीक है. सो इनपुट रेजिस्टेंस जेड इन. सो for BJT Zin is low. Clear है? So it require high bias input current. ठीक है, current. Now in case of fat, the Zin is very high, so less leakage current, so better thermal stability and low input bias current. ठीक है. Now अब जो फैट है वो दो टाइप के होते हैं. तो फैट इज हैविंग टू क्लासिफिकेशन, जे फैट एंड मॉसफेट. तो जे फैट का जो इनपुट रेजिस्टेंस होता है दैट इज 100 मेगा ओम ऑर्डर, बट इन केस ऑफ मॉसफेट इट इज 10 की पावर 14 टू 10 की पावर 15 मेगा ओम ऑर्डर. ठीक है. याद है. अब अगर हम इनपुट रेजिस्टेंस का इंक्रीजिंग ऑर्डर लगाते हैं, तो अगर मैं एग्जांपल की बात करूं, इंक्रीजिंग ऑर्डर, सो कॉमन बेस का जो इनपुट रेजिस्टेंस होता है वो 0 होता है. क्लियर है. फिर कॉमन जो इमीटर है उसका जो इनपुट रेजिस्टेंस होता है दैट इज मीडियम, इट इज मीडियम. देन वी हैव जे फैट एंड लास्टली वी विल हैव MOSFET. So it is the increasing order of resistance. R is increasing order, resistance increasing order. Clear है. So I hope so fourth point भी बिल्कुल clear हो गया होगा. Now fifth point समझते हैं. Fifth point, alpha, the temperature coefficient. या इसको हम बात करते हैं थर्मल स्टेबिलिटी कैसी है. थर्मल stability. So BJT is having less thermal stability. BJT is having less thermal stability. But your field effect transistor has better thermal stability. कैसे, जरा आप ये समझिएगा ना. जो फील्ड इफेक्ट ट्रांजिस्टर है that has property to change their alpha. Now alpha is positive in linear region, in linear/ohmic region, but alpha is negative in saturation/amplifier region. क्लियर है यहाँ तक? पक्का है. नाउ एक और जो रीजन है, पहला तो रीजन मैंने दे दिया लेस लीकेज करंट, सो लो इनपुट बायस करंट, ये इसका एडवांटेज है. नाउ इन फील्ड इफेक्ट ट्रांजिस्टर as temperature increases the mobility of charge carrier decreases. That's why these devices are having better thermal stability. I hope so ये point भी clear हो गया होगा. Now sixth point की बात करते हैं. now in case of IB characteristic, ठीक है. so अगर मैं बात करूं current and voltage is having exponential relation like the diode. So IC, or you have IE is equals to e की power BE upon N VT. Clear? But in case of FET, the output current ID equals to IDSS1 minus VGS upon BP का square. So we are having the quadratic relation. So we have quadratic relation. क्लियर है यहाँ तक? आई होप सो ये 6 पॉइंट भी क्लियर हो गए होंगे. नाउ नेक्स्ट 7th पॉइंट से स्टार्ट करते हैं. नाउ 7th पॉइंट समझते हैं. 7th पॉइंट, ऑपरेटिंग रीजन. ठीक है. सो अगर हम बीजेटी की बात करते हैं, जो बीजेटी इज ऑपरेटिंग इन एक्टिव or linear region for amplification. But FET is operating in two region. The first is known as the linear or ohmic region, and the second region is called saturation oblique pinch off oblique amplifier region. Now in linear region the FET, this is FET, is working as it behaves as linear resistor. But here it works as a constant current source. So this is the 7th point about the operating region. Now in the 8th point, configuration. ठीक है. Now how we can remember the configuration? Now if you remember, we have the common base, common emitter and common collector configuration. Now according to this, now C stands for the common, so just make common. Now base is replaced by gate because base is analogous to gate, so it is common gate. Then the emitter is corresponding to source, so common source. Then next we have the common collector, then collector is corresponding to what? Drain. So we have 3 configuration: common gate, common source and common drain. Now common collector is called emitter follower. So in the BJT, the emitter follower is called common collector, but in case of FET, the emitter follower is known as common drain amplifier. Clear है यहाँ तक? 9th point समझते हैं. gain bandwidth product. So in case of BJT, gain into bandwidth product is high. So here the gain bandwidth product is low. It is low. I hope so ये बात समझ में आ गई. 7th, 8th, 9th point. Now 10th point. Symmetry. ठीक है. Now in case of BJT, if we interchange the emitter and collector, then we don't get exact electrical output. But in case of field effect transistor, if we replace the drain and source, then we can get the exact electrical output. So BJT is asymmetrical device. That means emitter and collector cannot interchange. But FET is field effect transistor is symmetrical device. ठीक है यहाँ तक. That means source and drain can interchange. Now if you see the example, so suppose we are having an NPN transistor, we are having NPN transistor, this is collector, this is emitter, and this is your base. Okay, now this junction is forward bias, so this is forward bias, it is now forward bias, and it should be reverse bias so that the BJT is working in active region, or it can provide the amplification. Now if you interchange the emitter and collector, so it is P, it is N, it is N. Now it is emitter and it is collector. Now base is base. Is it okay? Okay, now minus is it is minus and it is plus. Sorry, it is reverse bias, so it is positive and it should be negative. Clear hai yahan tak? So if you see this junction, this collector base junction is now reverse bias, forward bias, and this junction is now reverse bias. Okay, reverse bias. So this junction is now forward bias and this junction is now reverse bias. Now in forward bias, the alpha F, beta F and gamma F are the different current gains in common base, common emitter and common collector gain. Then these gains are very, very high in the reverse active mode. So beta R and beta gamma R. Clear? So that's why the BJT is a asymmetrical device, but your field effect transistor is symmetrical device. That means if you interchange the source and drain, you will get the same result as previous. Clear है? So hopefully 10th point तक clear हो गया होगा. Next points देखते हैं. In the 11th and 12th point we will take the advantage and drawback. But advantage को समझाने से पहले मैं जो field effect transistor है उसके advantage को समझाता हूँ. Now field effect transistor is having more linear characteristic. Overload and peak current handling capacity is very, very high. Easy to parallel for higher current. That means its parallel operation is easy. Low leakage current. That means input resistance is high. No thermal stability because the alpha is changing. This JFET and FAT is having the property of changing alpha from positive to negative. So no thermal stability, and mobility is decreasing as temperature increases. Low turn off time. This low turn off time. So due to absence of minority charge carrier, these are having low turn off time. Zero input bias current because Rn is very, very high, that is infinite, and this is also due to Rn is very, very high. Clear है? Then zero input bias current हो गया है. Then 7 point excellent implementation as switch. This FAT is mostly working as a switch. That means switch from cutoff to saturation to cutoff mode. Less noisy. Now it is less noisy due to one type of charge carrier, so it is less noisy. Now require less space. That's why it is used in integrated circuit technology, that is ICs, in LSI and VLSI, that is large scale integration and very large scale integration technique. Lastly, it is having lower offset voltage. That is better choice for chopper में अगर आप पावर इलेक्ट्रॉनिक्स पढ़ते हैं, देन फॉर मेकिंग चॉपर वी यूज मॉसफेट. तो ये तो एडवांटेज हो गया. अभी इसी की मैं ड्रॉबैक की बात करता हूं. अगर मैं यहाँ पे इसके ड्रॉबैक को समझाता हूं तो इसके जो ड्रॉबैक है वो कम है एज कंपेयर टू इट्स एडवांटेज. तो पहला ड्रॉबैक क्या है? इट्स गेन इज लेस because gain is directly proportional to conductance. When conductance is less, so gain is less. The first drawback. Clear है? And it is sensitive to overload only. Overload voltage. So these are two main drawback of this field effect transistor, but have numerous advantage. Clear? That's why we prefer FAT over the BJT. Now next thing is what? The advantage of BJT is what? Higher voltage gain per amplifier stage. BJT has superior high gain, high frequency response and low cost. जब भी आपको अगर cost effective चाहिए, then you can use the BJT and lower conduction losses. Clear है? अब अगर मैं drawback की बात करता हूँ, FET की, sorry, BJT की, then it is more noisy because it is more noisy due to two type of charge carrier. Clear है? Then the next advantage is, next drawback is higher switching losses. Clear है? Then next drawback is thermally unstable. It is thermally unstable because at the collector we have more heat dissipation. Clear, and more leakage current in the BJT. तो ये तो हो गए एडवांटेज और डिसएडवांटेज. अगर मैं एप्लीकेशन की और बात करता हूँ, 13 पॉइंट, इफ वी सी द एप्लीकेशन पार्ट. सो एप्लीकेशन अगर आपको याद हो, कॉमन बेस, कॉमन इमीटर एंड कॉमन कलेक्टर. दिस इज सुटेबल फॉर हाई फ्रीक्वेंसी एम्पलीफायर, This is suitable for power amplifier, and this is also suitable for audio frequency. Sorry, it is suitable for audio frequency, and this is suitable for collector. It is collector na, so collector, that is IE. Collector is common, so output is IE and input is IB. So it is suitable for current amplifier. Now this is suitable for power amplifier, so it is voltage amplifier. ठीक है. अगर मैं फैट के एप्लीकेशन की बात करूं तो अगेन वी हैव lots of applications. So first is what? Calculators, handheld calculators. Then watches. Then we have in microprocessor, and in memories, and in integrated circuit technology. तो जो फील्ड इफेक्ट ट्रांजिस्टर है उसके एडवांटेज ज्यादा है, ड्रॉबैक कम है, बहुत सारे एप्लीकेशन इसी वजह से. दैट्स व्हाई वी आर प्रेफरिंग द फील्ड इफेक्ट ट्रांजिस्टर ओवर द बीजेटी. क्लियर है यहाँ तक? सो आई होप सो जो बीजेटी वर्सेस फील्ड इफेक्ट ट्रांजिस्टर है वो आपको बिल्कुल क्लियर हो गया होगा. ठीक है यहाँ तक?